Hi everyone, my name is Ryan Cooke. I am presenting the philosophy of testing at Pinterest, and I am presenting from quarantine in San Francisco. So I hope this is a fun experience for all of us. So first, to give a very brief intro to myself, I'm the engineering manager of the metric quality and test tools team. That test tools aspect of it matters the most for this. And I built a whole lot of the testing at Pinterest. We currently run hundreds of tests. We run on 4 platforms: Android, iOS, web, and mobile web. We have these tests run millions of times per month, several million runs per month. And what I want to share here is creating a general test principle that can help drive best practices, not just across Pinterest, but share what was successful at driving back best practices for us to other teams. So the overall plan is I want to give a brief history just so you can compare kind of the context I'm talking about and better understand what might and might not be applicable to you. Talk about kind of the problems that came up. Then I'll dive into the meat of the presentation, which will be the philosophy of testing. And then I actually will be online live. I'm not exactly sure how, but technology will make it happen for questions. So let's talk a little bit about the history of testing at Pinterest. Back in the dark days, we didn't have a lot of UI testing, but we actually came into UI testing from kind of a sideways angle that we needed a good way to ensure that our metrics were accurate. This was understanding how many pins people saw, how many active users were on our app. Logging it from the client we found was frequently bug heavy. So what we did was we, among many other texts, made a series of UI tests to protect it. We tried to use the existing suite at the time, and it was terrible. It was a team in complete isolation had built this test. It took 6 hours to run. Nothing was parallel, but really the greatest sin of it all was that the test always failed. Like they didn't have passing runs, so nothing was happening on failures. That was the state we were in several years ago. We are in a far, far better state right now. But that's kind of the state that we had when we decided we really needed testing to matter. So we came up with a priority, and our priority was we needed something that works right away. We needed specifically to solve the metric quality issue. And with that in mind, we built something very fast. It was built around metric quality testing. We threw away a whole lot of old tests that didn't matter. We threw out a lot of the code and focused on just having these few tests have no regressions. We paid kind of for external services to help us handle hosting and issues like that. And with that, we were able to kind of start catching regressions and really preventing metric quality regressions from happening through UI tests. Somewhat unintentionally here, we also gave everyone what I kind of call the gift of testing, right? Like now that we made a test suite, well, we'll say the gift of testing question mark. Is it really a gift? In that basically anybody could write tests using our architecture. They just would write their own tests, write their own things. The downside was they were kind of following their own best practices. So they were building things like these tests would only run nightly and we'd have somebody manage to check the failures. And lots of different kind of approaches to this, which both made it hard to maintain a central system, but also hard to kind of build for the future. So once we had actually built this suite and other people started using our test tool suite, we actually moved from a metric quality team to a metric quality and test tools team. We had built a test infrastructure that was scaled across hundreds of engineers, and we needed this to actually scale and actually work. We also realized that because we had just let everyone do their own thing, suddenly we had completely different solutions there. We had to kind of find the best and find ways to deprecate problems. So the second section, I'm going to kind of talk about the problems that we ran into with working on with other teams. What the main other problem was other teams. Thanks, guys. That was it. That's it for section 2. Other teams were the problem. I mean, they didn't know the best practices. There was no central guidance. And what we were going to need to build was a how to write test, not just from a technical best guidance, but for a procedural, strategic best practice. That's what really brought us to creating this philosophy of testing. So, our philosophy of testing had two key principles. And essentially, what we did was we took a step back and we figured out, why are we testing? What is the point of testing? And how can we best achieve these goals? So, the most straightforward and simple reason we are testing is the value of test is to prevent changes that cause regressions. Arguments could be made that they also provide value in making people confident that their change is safe, but we see that as a side effect of the test actually preventing regressions. They know that's not going to prevent regression, so they can safely change. That's really like the core of what it is. But in reality, there's another aspect of UI testing we felt that if you didn't think about, you were going to build a non-sustainable suite. That's UI tests are really easy to write. Like AIs were writing UI tests right now. I mean, really smart AIs, but AIs are writing it. You can record and replay. Writing a UI test is not the hardest thing to do. Where a lot of the cost for UI tests is maintaining them, keeping them stable, keeping them from being flaky. So we kind of accept it. Infrastructure's in place. You can write tests. That problem is solved for the company. We want to make sure when we give any guidance that it emphasizes if you build tests in such a way that will have more maintenance, that will not be sustainable and will not be successful. So from that, a whole lot of guidance came up. For example, the guidance, which is basically our conclusions from these. The most standard one is the slide I'm legally required to present because this is a testing presentation. It's the testing pyramid. I'm supposed to play. Yeah, testing pyramid, and it's ridiculous. It's in every one of these slides. But it's relevant. You've seen it 1,000 times. And the biggest and easiest thing to tell teams from this is prefer unit tests. That goes into a lot in principle 2, which is reducing the maintenance cost. They're running faster, they're more stable, and they scale better. There's good reason that the testing pyramid's popular. And we wanted to emphasize in teams, even though we had created this great usable automation test suite, it should not be the panacea, all your tests go to this. The other kind of aspect of this was we wanted to give people ideas of when to write UI tests. One of our guidance was a response to regression. It's an easy case that you had something that legitimately went wrong in production. You don't have an easy way to prevent it from happening again. That's one of the kind of the basic tests of a good software engineer program is you don't have the same issues happen twice. So if you had an issue, make sure there's something to keep it from happening. If you can't write a unit test, write a UI test. Beyond that, generally just basic coverage, especially in hard to unit test situations. Where this kit first came was the metric quality. We wanted to both exercise the pipeline and testing the individual functions did not do a great job because a lot of the metrics were related to UI actions. So that's why we had a very heavy UI test for that. But those were our general guidance of when UI tests do make sense. Beyond that, again, really emphasizing on principle 2, we emphasize make sure that these UI tests you write are high value. So the problem that we saw, this is a hypothetical, but what we're seeing was some suites were getting out of control. They were having thousands of tests for what could be a handful of tests. And what we saw was happening was they were coming from very reasonable kind of steps. They might have something like a login that actually has 3 different flows they want to test on it. Then they want to make sure that they test it on tablets and phones. And they're actually an Android team. So for Android, you want to cover all the different manufacturers. So you got to do at least 4 different manufacturers to kind of get this covered. And then there's actually 9 different versions of Android we support. So that's again another 9 versions of test. And suddenly for this 3 tests, you wrote 216 tests. And this again goes to that they're very easy to write. You could write these 216 tests in very not much more work than it takes you to write the 3 original tests. And while teams weren't going as extreme as this example shows, we were seeing that the temptation of making these simple variations on the same test was coming up a lot. So how do we kind of solve this? Well, again, we emphasize unit tests. Let's cheaper test. Don't go to unit test right away. One example I gave was testing different languages, where people might want to try UI tests for every language, but a lint would do a much better job of that. We also emphasize testing either the standard or the extreme. So this is useful when you're thinking about like what version of your app or what browser you want to support in testing. We'd recommend the easiest thing to do, where the majority of our test suites run, is where the majority of our users are. So this is the newest version of iOS or Android, or close to a newer version, or Chrome, frankly, for web. But also having just a small suite of tests to cover the extremes, which is to say, you don't need to test every single supported version of Chrome or IE or iOS. You just need to support kind of a test to make sure everything works in the newest version, and everything works in the oldest version. And while there is some risk there, it's likely that you'll catch kind of the cases that are in between with one of those tests. And again, the other emphasis there is that you're not running all your tests on each thing. You're doing a core test suite to make sure that there aren't any fundamental problems on this. This is all built around kind of keeping the test suite size sane and not having every variation of the test, that you don't need a test that does roughly the same thing but with a different type of user, when it's, if you actually think about it, it's exercising the exact same code. So just understanding what type of regression are you going to prevent, and if you already have a test that's going to prevent that regression, you don't need to add another test just to say you did it. Which kind of brings us to a problem that I've seen organizationally. Something that's very easy for a team that's just new to testing, just thinking about testing, is to say, we're going to go against test. More tests we have, the better. You know, but actually, we'll test more problems, or as we're graphed here, tests versus problems. So just flatly don't goal against having the number of tests. You can goal against like having this many of flows with test coverage. You can think about coverage, but simply aiming to have more tests is going to give you more problems. More poorly written tests is really what will cause the problems. Other kind of guidance that we got from this is you should run the test as close to the change as possible. As a lot of these have been so far, this is again going on principle too, that you need to keep the maintenance cost as low as possible. And this is going really on the shift left principle, which I would not be shocked if there's another presentation about. But if you kind of compare the idea of running tests overnight, when a test run overnight fails, you're going to be looking at any of the commit during the day. For us, that likely means 50 plus commits easily could be the cause of this test failure. And so now an engineer is going to have to go and look through the commit history and try to find something that's related. You could do a git bisect, but that's still going to be slow and complicated. And it's going to be just tedious for people to solve. While if you run it before the people actually land to master, which is where we aim to run all our tests, and we run the majority of our tests right now, then you actually just catch the problem. The engineer knows, oh wow, that was going to break something, and fixes it before it ever merges to master. That's easier said than do. It's been a big project for us, but that's our recommendation and our guidance. Beyond that, we can't emphasize enough how much stability matters. This again is the reducing the cost of how much it is to maintain. The less stable a test is, the more maintenance cost it's going to have. A lot of what we do to think about stability involves measuring stability. If we didn't know how stable our tests were, we couldn't tell you kind of what are the problem tests. So how we do this is every time a test runs, we allow 3 retries. Retries are okay, but they're also evil, which is to say that try to keep the number of retries as minimum as possible, and retrying by itself should be seen as a problem. So what we see is if a test fails, retries, and gets a different result, that is seen as a flaky test, which is a problem that we aim to resolve. And that is kind of just our basic math of how we measure it. And with that, we add the kind of 2 side effects that you only want to add stable tests to your suite, which is to say, don't add a test you've only run once to your suite. Make sure you have some system of making sure a test is stable, whether that's running 10 times, whether it's running in a non-blocking manner for a certain amount of time. Make sure you can be confident that a test is stable before you add it to a suite. And on the flip side, you need to remove the unstable test. What's really going to waste people's time is a test that fails 50% of the time, means nothing. They're either going to lose a whole lot of time investigating these changes, which then kind of you're getting into making your tests expensive to maintain, or worse, they're not going to investigate failures because they know the test suite is flaky and not useful. And then you're not going to be preventing regressions because that's the whole purpose of tests, is to prevent regressions. And if you're ignoring them, that's not going to happen. So I can't emphasize enough that every half we goal against stability, we aim to move it better and better. And we keep making tools that do things like automatically removing unstable tests and make it easier for our engineers to make sure that they have stable tests. We also emphasize that the failures need to be solvable. You need to isolate the tests from the problems that they can't solve. What this means is the simplest example is if we look at an API layer. If API is being committed different than your client, which it probably is, an Android engineer failing because somebody changed a search result, that's not going to be useful to have the Android engineer investigate it. You need somebody on the API team to know, oh no, I changed the API result that the client is expecting. I am the person who changed this. I think a lot of people like the intuition that you should mock the network and kind of isolate layers is pretty intuitive. Where I see this kind of stumbling at larger companies is around things like A/B experimentation and kind of these React Native things that give us further control, where we're used to having this standard release cycle, but with things like A/B testing, you might ramp an experiment up completely where there's no commit at all. And so how we kind of approach that mentally is we want all changes to have a detectable step. So for example, for experiments, how we have them in our test suite, and this is just an example, it's not the true fun, like the best way to do it, is that any experiment that's ramped above 50%, which means basically we've decided this is a good experiment to go forward with, will automatically be enabled for all the tests, while any experiment that's below 50% is, or at 50%, is disabled. This means that all the tests run in a consistent state, and then when somebody decides, yes, this experiment is good to ship, it actually treats it as its individual commit stage, so that instead of failing at the next person to commits test, it will fail the, oh, you cannot ramp this experiment up because it needs to handle the test suites, need to be updated. We decided not to force this as a blocking to ramp the experiment up at all, though, because we found it was difficult for them to write tests that would work in sometimes A, B, C, and D experiments. So we have them when you pick a winner, that's when the test suite needs to reflect kind of the winner scenario. Another idea that comes up a whole lot in our testing suites is that all UI tests have the same priority. It's easy to think about this and come to kind of a different conclusion, Where I see this going wrong a lot is we don't want developers to have to wait 30 minutes to get their test results before they can merge into master. We want to reduce the cost, and we don't want to run our 200 tests every commit. There's a lot of like legitimate pillars or reasons that you would want to have a lower priorities for test. Most of them are either going to be cost or speed, arguably stability too, if you want to make a like, here's our stable suite, here's our not stable suite. But we believe this is all kind of misguided, that you should only have one priority of testing. The reason for this is actually kind of the reasons we've discussed earlier about wanting to have your UI test running as close to the change as possible. What realistically happens when you start having a tier 2 of testing, say a test that runs every night and is not blocking, is those tests become less stable. They start to give a larger maintenance cost for your team, so that now you have your problem again, that the reason you're shifting them left was to reduce the maintenance cost. And now that you haven't done this, they're going to have a bigger cost in your maintenance. Or the other direction where this might go wrong is suddenly their failures stop mattering as much. People ignore their failures. And then they're not preventing regressions anyways, so why are you even running them? Because that's principle one, is prevent regressions. So we kind of have had the back and forth on this, and when it comes to reality, it's much easier to say all UI tests should have this top tier, very expensive priority. But if you're kind of following all these guidelines, all these tests are high value. They're all core tests. There are no tests that if these fail, they don't matter, or that if they get unstable, it doesn't matter. So because you're building all your principles and all your testing around that, setting them all at this, they run at the same time under the same rules, is generally going to set you up for success. The last core principle we have is really kind of about scaling. It is that basically testing is a team effort. It's exactly that, actually, is the conclusion you get from it. So what we mean by that is that we saw that early suite that Pinterest had, the one that was failing every time you ran it, and it took 6 hours. That one, which we had to completely scrap, got that way because it was not testing as a team effort, that there was this one small team that was responsible for writing tests. They didn't know about feature changes. Nobody would tell them, hey, we're completely rechanging how this page works. Suddenly their test would fail, and they just couldn't keep up with these overall failures. So they ended up with just this unsustainable thing, and they weren't placed in the org to win. So the real conclusion here is to have everybody work together. There is no, this team's job is to write test. You can have a team writing architecture, but every team needs to be both contributing to kind of writing tests and maintaining the test, and maintaining the test. We achieve this by actually having every test has a assigned team owner. We actually are considering moving this so that each team has an assigned component owner. So for example, sharing pins might be owned by a team, and then a test might relate to sharing pins. This would just make it more resistant as organizations grow and change. But what it's really helped us do is when a test fails, we can say, your team is responsible. Or when a test gets flaky, well, normally when a test fails, it's the committer that's responsible. But if it fails for a non-commit reason, then we go to the team. And if a commit gets flaky, what we can do on this is we make it so that we disable the test. We say, responsible team, you need to either fix this test or get it removed from the test suite, and we have it temporarily manually test it just while they're working on it, which we have a very short SLA to fix. So that is actually all of my principles. That's the core idea of how we think about testing. We do a whole lot more about goaling, where we set very concrete goals for our architecture. We also do a whole lot more about how we outreach to teams and how we show that they can run tests. This is purely meant kind of when they're asking, should I write a UI test? These are supposed to be principles to help them know where the test should run, how to think about it, and not fall into kind of some common pitfalls we have. Again, my name is Ryan Cooke. I have an email address. Feel free to email me. I will try to respond, but I should actually. I respond to most people do this. I also have a Twitter account. Mysteriously, I ended up with 2 underscores on that Twitter account. And I am the organizer for a local meetup that will not be meeting up until the end of quarantine. But it's automated testing in San Francisco. If you're in the Bay Area, I encourage you to join the meetup and stop by if you're around. I actually am going to try to come live for questions. If I change clothes, don't be too shocked. This was actually recorded in the past. Thank you. I really appreciate everyone's time. I hope this was useful. And so we have a lot of questions on the question tab. I'm going to just start going through them. Jai asked, when do you know a retried test is evil? So we actually we measure stability, or you could call it evilness of a test. So every time a test retries and gets a different result, which is important to say that a test retrying and failing 3 times, that's just a failing test. No big deal there. Like, I mean, it caught something, but it's not a problematic test. It's when a test fails and then passes, that is a problem. And so what we do is every time a test does that, we mark it as flaky for that run. And then we look at what percent of its runs are it's flaky. And that gives us like, if you ran this test 100 times, you would expect it to produce the same results 100 times if it's 100% stable. Or if we were seeing it run flaky 10 of those times, it would be a 90% flakiness. And then as a org, we go for overall suite to be 97% stable, which means that basically out of 100 runs, if you get 3 retries and different results, that's problematic. Some of our lower hanging tests are worse than that, but basically anything that's less stable, that's what automatically gets marked as this is too stable to be a blocking test. So you're talking no one. Okay, going down. When flaky tests are being manually worked on, how is this metrics related to that feature reflected in the test report? So there's a few kind of ideas of what we do. So say there is a flaky test. It's something happened. It's failing every time. So we completely silence it. It doesn't block commits anymore. For mobile, this is a little easier because we only release mobile once a week. In which case we create this dashboard that says, here are all the automated tests, and then we have a manual team actually for the mobile release will verify and mark off of that this test is not stable enough to pass, or mark off that they manually tested that test and that it passed the criteria. They will do that until we say, no, this test is not worth continuing to test. So normally this is very few tests, kind of. If it's more than 2, it's a problem for us. But then we actually do have an overall dashboard. This is especially important for SOX, where we have tests that are protecting the billable metrics. SOX is a public company thing that's really annoying, we're discovering, but really valuable. And we just verify that they get manually tested in a custom dashboard we built. Hopefully that answers. I somewhat discussed on stable, unstable stability percentages. The terms always get a little bit convoluted, which so like we'll use flakiness, which is the opposite of stability. The easiest way to say it is that if you took 100 test runs of it's the stability percent, which is normally what we think in, is the amount of times you expect that test to get the same result. It could be 100 failures, but as long as it's the same result, we'd call that 100% stable or 0% flaky. But if it was 25 failures out of 100, we'd call that 25% flaky and 75% stable. What is your opinion on? So I am not familiar with this tool. I will quickly go into it, but I have one more thing. I am skeptical. that they can reduce all possibilities for flakiness. Flakiness comes from user account management. It comes from network problems. It comes from the server failed on us. And so like there's just enough sources that I'd be skeptical, but I haven't really gone into the tool at all. I think I am about at time, but overall, I really hope that was useful. Again, you all have my email, so feel free to follow up.